Welcome to my course final project presentation on big data case study in marketing topic. In this project, I used a bank-time marketing dataset to train and evaluate predictive models using logistic regression and gradient boosted tree models, and also show you how to build an interactive UI using Shiny app and how to create a dynamic report using R Markdown and neat-R. First of all, let me start with a very brief background introduction. Why choosing this project? Marketing nowadays is no longer an art form. Big data has become more and more important in the decision-making process for marketers. It has been proven to help improve marketing efforts in a lot of different ways, such as better customer profiling, customer engagement optimization, market research performance optimization, competitor analysis, and so on. Effective big data analytics has been used by a lot of different brands to help them achieve better branding strategy, targeting strategy, budget management, and also to improve their customer retention and acquisition results. They are also trying to use effective big data tools or analytics to help them develop distinct competitive advantages over competitors. Predictive modeling is also very important, especially in customer acquisition and retention. For customer retention, predictive models are usually being used to predict churn, meaning finding users or people who are more likely to cancel subscription to a service. This is a very important topic, especially to the subscription-based business such as Netflix or AT&T and other phone services. On the other side, for customer acquisition, predictive models are usually being used for creating better targeted audiences to achieve better marketing campaign results. This is also the use case we'll be focusing here in this project, to use predictive models to achieve better targeted audiences. Although there are a lot of different tools to achieve similar goals for big data analytics in marketing, the core pipeline or the general idea actually is not very different from each other. The general idea is usually almost the same or very similar to each other. Therefore, the project goal here is to provide an implementation of binary classification modeling process with different technologies. So here we'll be using R and PySpark to achieve similar modeling and evaluation goals. And also I'm trying to build a data handling, modeling, evaluating, and reporting pipeline that can be used to predict a marketing campaign recipient's response. And also I'm trying to introduce generalized boosted model, in short GBM, as a very powerful but very memory-consuming machine learning algorithm for regression and classification. In the last, I would like to demonstrate how to build a user-friendly interactive UI using Shiny app and how to create a reproducible dynamic report using R Markdown and neat-R. The data used in this project is a bank telemarketing dataset created by Paolo and Sergio. Sorry, pardon me if I'm not using the right pronunciation. The details of this project are described in one of their earlier papers. The download link is where you can download this dataset from. The data is related with direct marketing campaigns of a Portuguese banking institution. It has a list of input variables, including information on the bank client, information on last contact of the current campaign, and some other attributes. Y here is our dependent variable showing whether the client has subscribed a term deposit. Our classification goal will be trying to predict if the client will subscribe a term deposit or not. This page shows detailed information about input variables, including the variable's name, type, and also the descriptions. You can see from variable number 1 to 9, these variables are information about the bank client. So, such as what is the age of the client, what type of job does the client do, education level, whether a client has housing loan, personal loan, or what is the yearly balance of each client in account. And the next few variables are variables related to last contact of the current campaign, such as when was the last contact done, which day of the month, which month of the year, and how long did the last contact last in duration, in seconds. It also has a few other attributes, such as the outcome of the previous marketing campaign, and also the last one is our dependent variable Y, showing whether a client subscribed a term deposit. MLLib is something that we have already covered in one of our earlier lectures, so we won't be talking about this too much. Generally speaking, MLLib makes practical machine learning scalable and easy. It consists of common learning algorithms and utilities including classification, regression, clustering, collaborative filtering, and dimensional reduction, as well as lower-level optimization primitives and higher-level pipeline APIs. It is actually divided into two different packages. The first one, MLLib, is built on top of RDDs, contains the original API, and the second one, ML, provides higher-level API built on top of data frames instead of RDD here. So generally speaking, the second package, ML, is actually more flexible compared to the first one, MLLib, because it's built on top of data frames instead of RDDs. In this project, the implementation will be using two classes here. The first one will be used to implement logistic regression. We'll be using PySpark MLLib classification logistic regression with LBFGS. And the second one will be PySpark MLLib tree gradient boosted tree to implement our gradient boosted tree models here. A quick introduction on Shiny. Shiny is an R package that makes it very easy to build interactive web applications straight from R. It has been a very popular tool due to its high customizability, great visualization possibilities, and also easy sharing features. It also provides a timely, high-quality interactive data experience without, or at least without too much web development and without the limitations or cost of BI tools. Usually, a Shiny app consists of two parts: a UI script controlling the layout and appearance of your app, and the server script will be controlling the instructions that your computer needs to know to build your app. To install Shiny, it's very easy. You can just run install.packages and then Shiny as the package name in R. To run an app, you have to put the two scripts, the UI script and also the server script, together in the same directory. At a minimum, a Shiny app has to have these two scripts at least. And also you can create a subdirectory called www if you want to add some styling or add some images to the app. We'll be talking about this later. Shiny also supports a lot of different ways to share your app. You can either share your Shiny app to run locally or deploy your Shiny apps over the web. There are several pros and cons if you choose different approaches, but generally speaking, it's very convenient and very easy to share your apps. R Markdown provides an authoring framework for data science. You can use a single R Markdown file to both save and execute code or to generate high-quality reports that can be shared with an audience. NeatR is an engine for dynamic report generation with R that enables integration of R code into a lot of different types of documents. To install R Markdown in NeatR, it's very easy, convenient, and similar to what we did before for Shiny. We'll just run install.packages, whatever the package name is, in the brackets. So how does it work? When we run render, R Markdown feeds the .rmd file into NeatR, which executes all of the code chunks and creates a new Markdown file in the format of .md. This document will include all the code and the output. Then this Markdown file generated by NeatR is processed by Pandoc, which is responsible for creating the finished format of the document. Now we can move on to the demo part. The PySpark demo part will follow an overall procedure from reading and parsing input, encoding variables, extracting features, to training and evaluating of the two models. The first model will be a logistic regression model, and the second model will be a gradient boosted tree model. This is a screenshot of what you will see in PyCharm after you execute the code. This is the second part of the modeling output in this screenshot. We will also be comparing different test metrics for logistic regression and gradient boosted tree model here. I split the data into a 75% training dataset and 25% test dataset here. And all of these three metrics are built on top of the 25% test dataset. So we'll be looking at the prediction accuracy, area under ROC, area under precision curve for the test dataset with a model from logistic regression and gradient boosted tree. As we can see from this table, the performance of gradient boosted tree model on the test dataset is not much better compared to logistic regression, but it's only slightly better. But when we look at the execution time for logistic regression and gradient boosted tree model, it only took 7 seconds for the logistic regression model to train, but it took 340 seconds for the gradient boosted tree model to complete. This is much, much longer compared to logistic regression. That's also why when I introduced gradient boosted tree model, it's a very powerful machine learning algorithm, but very time and memory consuming. It also has another problem of being more prone to overfitting. That's why we have to be super careful when we implement gradient boosted tree model in practice. You might wonder, what is the difference between the gradient boosted tree model compared to other tree-based models such as random forest? Well, gradient boosted tree model is a boosting method which builds on weak classifiers. The general idea is to add a classifier at a time, so the next classifier is trained to improve the already trained ensemble. But the other tree-based algorithms such as random forest Each iteration, the classifier is trained independently from the rest. So that's the key difference between gradient boosted tree model compared to random forest. The R modeling and evaluating part is actually following a very similar procedure as what we did using PySpark MLLib. It only adds a few extra steps to make sure the results are more statistically robust and reliable. For example, it adds a p-value checking step to remove non-significant variables, and then VIF, which stands for variance inflation factor step, to remove the multicollinearity issues. To visualize the model performance, we're going to look at several plots, including the ROC curves for the test dataset and training dataset, and also a confusion matrix plot. For the gradient boosted tree model implementation in R, we're going to look at the final model relative influence. So here we can see from this plot, the previous contact duration is actually the #1 variable when we look at the relative influence. It actually makes a lot of logical sense, right? Because if a client was talking to a customer representative for a pretty long time, it's probably showing this client is very interested in this deposit offer. So it's more likely the client will subscribe a term deposit in the end. This plot here on the right is a plot showing how does the loss function changes as the number of iterations increases. This dashed line here indicates when did the loss function stop descending very fast. So that's the number of trees, or that's the number of iterations that we are going to apply in the end. We are also going to look at ROC curves and also confusion matrix here, similar to what we did for logistic regression model. The demo will also create an HTML report using the R Markdown file. The HTML report will look like something like this. So you can open the HTML report in your browser. It's going to look like this with embedded R code, R results, and plots and graphs. The final part of this demo is to create an interactive UI using Shiny app. This is what the UI is going to look like. It's going to have a sidebar panel with different input variables that user can change. A user can change what type of data visualization plots he would like to show on the main panel, and also what are the modeling parameters they want to use for creating the gradient boosted tree model. So they can change the distribution family, number of trees, learning rate, and also cross-validation folds. Although it's not here, but it's actually one of the other options that you can see after you open the interactive UI. On the main panel, you are going to find some text on the top and also the data visualization plots on the bottom. These plots are going to be updated once you select new parameters. For example, we changed the parameters on the sidebar to only visualizing using variables plot, ROC plot. I don't want to show the loss plot on the main panel, and I want to add logistic regression to compare the results between logistic regression and gradient boosted tree models. I also want to change my gradient boosted tree model parameters from Bernoulli distribution to distribution and decrease the number of trees from 1,000 to 500. And I want to increase my learning rate from 0.1 to 0.2 and do forward-fold cross-validation. This is how the plots are going to look like after we select the new variables. As we can see from here, the ROC curves are actually much worse for a t-distribution compared to the ROC curves that we saw for a Bernoulli distribution. This is the UI that we can open in the browser. It's going to have an embedded image. That's the image file that we put under this www subdirectory of the Shiny app. And also, you can change what are the modeling parameters you want to select to have the updated results. For example, I want to change it to Poisson distribution. I want to do 800 trees. I want to change the learning rate to 1.8 to 0.18. I want to do forward cross-validation, and then click Update View. So the view will not be updated unless you click this button here. It's going to take a while for the plots to be updated because it's running a totally new gradient boosted tree models using your new input parameters. So this is how the plots will be looking like after you have the new set of input parameters here. I can also include logistic regression, remove a loss function plot, and update view. It's going to look like this. This page shows a list of output files that you are going to see after you execute the code, the R part of code. So you are going to have a new subdirectory called GBM and another new subdirectory called logistic regression created under your working directory folder. You are also going to have a new file called rmarkdown.html. It's an HTML report that we generated using R Markdown init R. Hope you can find something interesting and helpful from this demo, and thank you very much for watching.